Okay, cool, perfect. So thank you, or tack, as you'd say here in Sweden. I don't have much Swedish to give you during this presentation, being an Irishman, but I'll throw in a few more words next time around, hopefully. So to introduce myself, I am a data science consultant. I'm based in Ireland, and I regularly work with different organizations in helping them implement business solutions using machine learning technologies. And what I'm here to talk to you about today is audiovisual data, and more specifically, how we can use deep learning technologies to analyze audiovisual data and how we can extract the best value out of this data. So we're all big data enthusiasts here, so it's not going to surprise any of you when I say that 90% of today's data was created in the last 2 years. But the more pertinent question is, where exactly is this data coming from? What's the source of this data? And really the answer to that lies in audiovisual data, or in other words, image, audio, and video. And really, with the advent of social media in the past 10 years, the amount of audiovisual data that we have at our fingertips has skyrocketed. So if you take Instagram as an example, people are telling their stories by uploading videos, by sharing pictures. Even with something as simple as WhatsApp, we're not texting as much as we used to. People are recording voice messages, they're sharing videos, they're sharing images, what have you. So the big challenge for us as machine learning enthusiasts is, how can we take this data and use machine learning in such a way so that we can extract the best value out of it? And by the way, I know everybody's coming in for lunch, so feel free to stand up, stretch your legs if you have food coma. That was some advice given to me from Grogan. So in terms of the applications of audiovisual data, well, I think it's fair to say that there's no industry on the planet that won't be touched by audiovisual data in one form or another. So just one example of this, and we touched on it earlier in the presentations today, was autonomous vehicles. So audiovisual data is a huge deal in terms of autonomous vehicles because it is allowing different vehicles to be able to be trained in such a way that they can drive themselves. And it's the epitome of machine learning because we have a device that is getting data over time, and it is using machine learning to process that data. And that's not the only thing in transport that's being impacted by this. For example, train tickets. In the future, people won't buy train tickets as we know them conventionally today. People instead will use facial recognition to be able to board a train. So really, the commercial applications of audiovisual data, there are a myriad of applications, and in the future, machine learning with audiovisual data, that will be the norm. It won't be the exception, it'll be the rule. So what I want to do today is give you an understanding of how we can apply machine learning frameworks to audiovisual data. So there are three things we're going to be covering. The first thing you're going to see is how we can classify images with Keras. You're going to see how we can work with videos in terms of splitting a video into different frames, and you're also going to be seeing how we can transcribe some speech to text. And this is all done in Python, by the way. So just before we get into all the code, all the nitty-gritty, just a show of hands, how many of you have worked with neural networks before? Yeah, most of you. No, that's an insult to your intelligence to ask you that question. But anyway, just to briefly go through it. So in a neural network, you have your inputs, where all of your data is coming in, and you have your output, where you are getting your results or your classifications. And in the middle of all that, you have your hidden layers, where the network is being trained through propagation. And from an analysis standpoint, this allows us to get much more accurate and much more detailed results than we would otherwise. So, for example, if you were a statistician and you were using a basic linear regression, you'd plug in your variables, your data, you'd get your output, and that could give you fairly accurate results depending on how you work it. But neural networks do much more extensive training, and you're going to be seeing why this is important with regards to audiovisual data as well. So what I'm going to do is I'm going to show you up close exactly what we're going to be doing here. So we have an image of a car, and we also have an image of a plane. And what we want to do is we want to train a machine learning model to be able to tell which is a car, which is a plane. So you can see here we have 80 images in our training set for planes, 80 images for cars. So that's what the model is going to be trained on. We also have our test set, or the 20 images that the model is being validated against to make sure that it actually works. So this is our code in Keras, and this is on the GitHub repository, which I'll give you at the end, so you'll be able to work with this yourself. So we're loading up a Python terminal. And this will take about a minute or so to run. Some models take days, but unfortunately I don't have that long. So you can see that our model is now being trained on all of the images that you've just seen. So you can see that the accuracy of the model is increasing as it's being trained, and the loss of the model is also decreasing. So by accuracy, we mean the classification accuracy, how accurate is the model in telling us whether the image is of a car or a plane, and then our loss is the degree of error in our model. How frequently will it make a mistake in terms of classification? So you can see that this is running. And in neural networks, what we're doing here is we're using a method called propagation, and we're running different epochs. So this is really the number of times that we're training our neural network. And the general rule of thumb is the more complex your data, the more iterations you're going to have to run and the more data you're going to have. So you can see in the first instance we have an accuracy of 82% on the training data, 82% again on the test data. And again, like I said, training versus test data. So we're training the model on the training data and then validating whether it actually works on the test data. Because if we feed images into the test data that we already have, then that's going to result in overfitting, and it's not going to do what we want it to do. So I'm just going to pause this a second because you can see that our model has been trained. And we have two unseen images, one of a car, one of a plane. So what we want this neural network to do is correctly identify whether it's a car or a plane. So we can see that it's identifying a 1 here because it's a plane. So you can see that our directory here, 56315795, that's the image of the plane. So it's correctly identified that. And now what we're going to do is we're going to change the directory to the image of the car. When we run this, we should get a reading of 0, and we do. So this is just one example of how we could use machine learning to classify images. Now, this example is relatively simplistic because it's fairly easy to distinguish a car and a plane. So we were able to do this with 100 images in total for a car and a plane. But if you're dealing with a more complex problem, let's say you want to be able to train a model to recognize faces, for example, that's going to be a much more complex task. So you're going to end up running many more iterations than you would on this example, and you're going to need much more data. So you're going to need hundreds of thousands, maybe even millions of images to be able to get really high degrees of accuracy in terms of doing that. So just to put some graphical illustration on what we did. So we're predicting the classification of the image, and the model loss is describing the degree of error in our data. So you can see that between 2 and 3 epochs, the validation loss or the test loss was at its minimum. So that's why we decided to run 2 epochs in this case. And on the other hand, for model accuracy, you can see that we have about 92.5% accuracy. So when I ran this on 20 epochs first, these are the readings that came up, and then we decided that we'd run it on 2. So when we've looked at image classification, if we were to take a step further and we were to extrapolate and analyze how we could analyze video. So when we're doing that, what we're essentially doing is we're extracting frames from the video. In other words, we're extracting all the possible images that the video contains, and we're choosing to analyze those. So what we need to be able to do to conduct video analysis is to be able to actually extract those frames first. And the way we would do that is using CV2 and Python. So this is just a very brief 20-second video. So nice scenery in Ireland. I recommend it if you are taking a trip out there. So that's a very basic image, and what we want to do is we want to extract all of the individual frames from it. So you can see that we're copying our code here. We have another Python terminal opened up. And you can see now that the directory, it's now being filled with all of the individual frames from our video. So if you wanted to do image classification the same way that we did in the last example, it would be a matter of first using CV2 to extract all of these different frames, and then conducting image classification on that. So you can see that our first frame is here, all the way down to our last. So we have just about over 690 frames in that video in its entirety. And what I also want to talk to you about is speech recognition. So when we're looking at analyzing videos, we've dealt with the image component, but we also have the speech component. And one of the most fundamental things that we're going to want to try and do is transcribe voice into text, i.e. speech recognition. So what I'm going to do is I'm going to load up just one last video for you. And this is me talking, so I can take a break. So you can see, hello, my name because my code is just being transcribed by Python, which is what we built the program for. Okay, so fairly self-explanatory. So what we were doing there is we built a basic speech recognition algorithm in Python to be able to transcribe voice into text. And really, that's that algorithm in its most simplified version, but there are cases where you could have, say, for example, noise interference or something else where the voice isn't clear. So usually what people would need to do is come up with something more advanced, like, say, a noise reduction neural network or something similar, a similar machine learning model to be able to deal with that. But anyway, what we've seen is how we can use machine learning to conduct audiovisual analysis. Now, these are very simplistic examples, but audiovisual analysis is going to play a huge role in the economy going forward and in data science in general, because all industries stand to be impacted by this. And really, as machine learning practitioners, dealing with this type of data is going to be the norm. It's going to be the rule and not the exception. So you've seen how we can use machine learning to conduct audiovisual analysis, how we can use Keras, speech recognition, CV2 to work with image and sound and video. So that's all from my side. Thanks for your time. You can find all of the code that I just described at my repository, so happy to take any questions in the meantime.